Okay, so I think the people will be joining us during the session. So I suggest to start now. Good morning to all, and thank you for your participation today. We're organizing the third workshop today of the virtual marketplace, CLAMTEX virtual marketplace, and our focus will be on automation and sensorization solution for performance improvement. Before to introduce our speakers and the program, I would like to remind you some basic information. So for your information, this webinar will be recorded. The video will be available later. So if you want to listen again to the exchange and the element that will be presented today regarding the question, we will ask you to write your question directly in the chat. Myself and my colleague will be monitoring this, and we will address them to the speaker during the question and answer slots. For your information, in any case, please know that through the B2Match platform, you can also write messages to the participant of the virtual marketplace, and you can also schedule B2B meetings if you want to have further exchange and longer discussions. So our program today, as I was saying, the focus is on automation and sensorization solution for performance improvement. We will start with two inspirational success stories. The first one will be from Gilberto Loureiro about Smartex technology, and then we will have Pascal Casari from CAPACITÉS, who will present the monitoring of technical textile they have been working on. After that, we will have the future challenge of the textile industry that will be presented by three companies. We will have Rui Sousa from Somelos, Jorge Mateix from Belda Lawrence, and Jordi Mota from Esima. And then during the advanced manufacturing solutions slot, we will have Patrick Caldamon and Dominique Bedway from Ceribas, who will present printed electronic solutions that could represent some transferability potential for the textile industry. At 12 and until 2, you have the slot for the B2B meetings, as we explained at the beginning of the event. This is an opportunity for you to exchange further with the company. So without further delay, I will invite Gilberto Loureiro to do his presentation. So just a few words about Gilberto. Gilberto is passionate about technology and textile, where he has been working since he was 15 years old as a textile company inspector at a small factory in Barcelona, Portugal. His main goal is to contribute to fully digital industry and supply chain, where technology serves humanity with automated activities and providing a clean, sustainable, transparent, traceable, and minimum waste textile industry. So, Gilberto, the floor is yours for the presentation. If you can share your screen, we'll listen to you. Gilberto, can you hear me?
Yes, I can. Let me just share my screen. God damn it. I'm so sorry.
No
I'm
problem.
now using another computer. I'll need to quit and reopen the platform to share my screen. I'm so sorry for this. Let me start.
Okay, so just technical issue.
Okay, now I guess you should allow me to share the screen. No?
Yeah.
Here we go. So thank you for the kind introduction, Luisa. I hope you all can hear me well and see my screen properly.
Yes.
Yeah, great. So again, so as Luisa presented, my name is Gilberto. I'm a Portuguese entrepreneur. I'm currently living in Portugal, in Porto, but I've been living in San Francisco and Shenzhen over the past years to develop this amazing technology that we propose to improve the textile industry automation and also to dramatically reduce the textile industry defective waste, which is a hell of a problem. I will show you details later on. So as many of you probably know, the textile processes, the textile industry in each stage has several parts of it where there are defects and wastes due to some inefficiencies, because we are working with a raw material that is not perfectly controlled, because we are working with natural fibers, etc. The speed of production is higher and higher. So it's absolutely normal and acceptable for every textile factory to have 1% of textile waste, or 3%, sometimes 5% of textile waste is acceptable because it's the way the industry works for centuries. Okay. However, there got to be a better way to do this production of textiles without so much waste, because if you see these 3%, looks like a small number, but if you take into account the volumes of production of an average textile factory, as well as the gross margins of a typical textile factory in the knitting stage or weaving stage, 3% can represent a big slice of the company profit. So this reduces a lot the company's gross margins. This damages the environment, of course, and also because typically the textile prices come from yarn to fabrics, and all the processes have multipliers in the pricing. This waste propagates until the end of the chain, so it affects directly the retail prices as well. So the textile industry is one of the largest in the verticality industries. Sometimes you have the yarn being spun in India, but the knitting is done in South Europe, and then the dyeing could be done in North Europe, and then the garment is done in cheap labor countries typically. So this is the way the industry is spread all over the place. Sometimes these folks, they don't talk with each other when they ship raw material from one side to the other, and the communication is based many times on trust, is based many times on human inspection. They need to have several human inspections in each of these stages just to make sure that the knitting manufacturer is exporting quality goods and the dyeing house is importing quality goods. So they have two inspections that add costs, add more prices to the material, but don't add any value. So that's one of the things that we at Smartex, and as well with Tintex right now, we are trying to collapse all of these miscommunications and digitize the way that these folks talk with each other with digital tools, right? So for those who don't know, this is a circular knitting machine. I usually present these types of slides for venture capitalists in Silicon Valley. So when they look to this slide, they think this is a time travel machine. But this is actually the fastest way to produce fabrics that the industry knows. I work with these machines for more than 10 years. It's a beautiful engineering machine. So as you see, there is a textile roll being produced down there. And as you can imagine, it's quite not easy to have a person inspecting this textile roll in real time, right? You cannot have a person inside that crazy machine to inspect it in real time. So we actually need the roll to be ready and then cut it out and inspect it later on. But meanwhile, the roll could be already full of defects and it will become garbage sooner or later, but you never know until you've inspected it, okay? And if you are lucky, we will inspect it with your human inspection people right after the knitting stage. But many times what happens is that this inspection doesn't have 100% guarantee or 100% inspection, so they do it by sampling. And many times these defects and faults go to the dyeing stage and then go to the garment stage, and eventually we have a Nike t-shirt for $50 costs that could be avoided, and it's garbage, but could be avoided if you detected that defect. in the knitting stage, where the fabrics cost like €3 per kilo. So in a nutshell, this is the Smartex solution. Okay, this is what we have been working for several years since college. Is basically, in a simple way, a bar with cameras that you can plug and play inside circular knitting machines, weaving machines, whatever machines that produce a roll-to-roll basis. So we can take photographs of everything that is being produced in real time, store those images to the cloud. We can do a lot of beautiful things with these images. We can use machine learning algorithms to inspect the fabrics in real time, so we can detect tiny defects like lycra lines or thick yarns or thin yarns here and there, tiny holes, and we can intervene in the machine immediately if the client wants. We can stop the machine, for example, or alert the employees in real time. And we also can do other services in the online platform that we provide that I will explain later on. So in terms of the business model, this is another consequence of such technologies that depend on cloud and on software services. We have, of course, an installation fee, but inevitably, we have also a monthly or a yearly license for all the software that runs and supports such technology. The idea here is just to make sure and guarantee that wherever the price of the yearly license, it needs to be like 5 times lower to 10 times lower than the current costs with current solutions of having people inspecting textiles or having the waste for defective production, etc., etc. So just to let you know that the company exists since 2018. However, last year we were able to raise priced seed rounds in the US with some of the best in business, like Spider Capital, SOSV, and Data Collective VC, some of the largest venture capitalists in the world, as well with the kind participation of Fashion for Good, which is a fund supported by amazing fashion brands like Adidas, PVH, and Kering, etc., that support us with lots of pilots, especially in luxury parts of the industry. We also were very fortunate to have access to the EIC SME instrument of $2.2 million US dollars in the same year. And so just to let you know a little bit about the reason why I'm speaking here today about this success story and about this partnership with Tintex Textiles, which is a Portuguese manufacturer that has the knitting house and the dyeing house, so they feel the pain twice whenever a defect happens in the knitting stage, or even it could be a yarn defect. Many times it's a yarn defect, but no one knows that's a defect until they mash it together in the fabrics. So these folks from the beginning, they know that their production has room for improvement, as everyone should know. There are no perfect factories or no perfect machines. So once we were in Shenzhen, in China, we received the kind invitation from Tintex to develop this product together with them. So this is one of the machines that we have in their factory in north of Portugal. They have, if I'm not mistaken, 20 machines like this, and we already have our devices in 6 of them. So this is our product looked from outside. You have a small tablet, a small user interface, and then you have a bunch of cameras inside the machine that typically the employees don't need to interact much with them. So what we collect from here is these digital assets, which are images, right? So we collect images of their single jersey production, their piqué fleece production from lyocell yarn or raw organic cotton yarn, etc., etc. So since we catch these images all in real time, we provide many other services, and that's one of the good things to be with Tintex, because they feel the pain in the dyeing house, so we can also track information to the dyeing house, like the roll maps. We can reconstruct the roll maps and have a digital version of the roll with all the coordinates of all the problems and defects and meters and velocities of production and efficiency of that machine, the time of the day that fabric was produced, which rotation it was, the speed of that rotation, and who was the employee interacting with it, and production order, etc., etc., etc. So the roll map is very useful for them because they will match the roll map later on in the dyeing house and in final inspection of the finished fabrics. We also provide user interfaces across the factory and online platforms where they can see real data and real-time images, real-time alerts, and they can also change the sensitivities of detection of our devices. And last but not least, by the end of the week or the month or whatever, they can export information about the quality of their production, like how many defects did they produce, what types of defects are more needle defects or yarn defects or lycra defects, elastan defects. So they can have a sense of what are the size of the problems that they have in the factory from the scratch inside the circular knitting machine without waiting for any human intervention. So with their help, we were able to calculate more or less the impact of every single Smartex device in every knitting machine. So there are many ways to calculate it, and for these numbers that you see here in the right corner, we are not calculating any sort of human salary or any sort of replacing humans. That's not the goal here. The main and I would say 95% of the savings are by raw material savings. So every time the Smartex device intervenes in a machine, it is avoiding the machine to continue to produce defects, because these defects, some of them are periodic. So when the Smartex device stops the machine from a periodic happening, so we calculate the savings of the amount of fabrics that we didn't waste because of that. And if we continue to calculate the savings in the dyeing house, because that fabric is not going to be dyed, that fabric is not going to be to use water or energy or chemicals or whatever, we can realize that the Smartex device savings is around $1,000 per month per machine. And this number is being confirmed and confirmed over and over in our current clients in Italy and Turkey and many other clients in north of Portugal as well. So the impact is really amazing in terms of financial impact, but also the sustainability point of view is also very impressive. The amount of water that we don't need to use, the kilograms of fabrics that we don't need to waste, the time of production that we also avoid producing waste fabrics. So this is very impactful. And it's just by having the inspection, not in the inspection table, but inside the knitting machines or the reading machines in real time, because we can actually avoid things to happen. We don't need to wait for the inspection stage to check it out. All right. So just to let you know that we also built together with Tintex an online platform, so they can have access to their machines everywhere in the world, and they can see all the crazy defects they produce, as everyone produces. Okay, Tintex is not the only one that produces defects. So they can see the performance of their machines, how many meters they produce per day, per shift, per employee, per type of production, per production order, the efficiency of the machines, roll maps. They can share roll maps with their clients just by sending a link if they want. So it's like the Facebook of the textile rolls. It's the digital version of a textile roll. I don't need anymore to send you a textile roll for you to make sure that you are buying extra quality fabrics. You just can open a link and you have the Smartex report in the other side of the world, and then you can confirm the order and you can ship it and pay for it. That's one of the traceability parts of the technology as well. Yeah, just a last slide just to finish. It was really great to see that we still have this type of early adopter mentality, because we have been developing this technology in China, in our offices in Shenzhen, in this beautiful city. And it was very funny to receive an invitation from Tintex, from Ricardo and from Pedro Magalhães from Tintex, to check it out, their production, to visit their facilities and to install in there. And just a few words about this is that there are many advantages for Tintex to be the first one to try it, or to be one of the first to try it. It is massive customization, because many of these features and many of these ideas were asked by them for them because of their type of production and because of their way of organizing themselves. And of course, there are special commercial conditions as well. Once the product was released by the end of last year, the prices and the conditions are different from these type of mental early adopters mentality, and therefore it is such a great pleasure to work with real industries that still support technologies that can create a real impact to improve the world. So just a final word on that, and cheers to Tintex and all the team, because they are really inspiring and help us a lot. And that's it, Luisa. Thank you a lot. And if you have any questions, please feel free to shoot me.
Thank you very much, Gilberto, for this very nice presentation. I don't see any question yet in the chat. So I suggest, okay. Yeah, so I suggest to continue with the second presentation, and in any case, we have a slot for question and answer after the two inspirational success stories, so we can address them later. Please, for the participants, do not hesitate to write your question and address them to the speaker in the chat. So we will continue with Pascal Casari. So thank you, Pascal, for being here. Pascal is professor at the University of Nantes and expert at CAPACITÉS, the private subsidiary of the university. He is specialized in composite material and structure with 28 years of experience in leading-edge applications like aerospace and racing yachts. Pascal, the floor is yours.
Okay, thank you, Luisa. Can you see my screen properly?
Yeah, you just need to pass it at the full screen if possible.
Okay, the thing is I had a second screen and I think I should escape and share one more time. So let's try to share the screen once again. This one, share, and then F5. No. One more. Okay. Share. Is it okay with that?
Yeah,
okay.
Perfect.
Good morning, everyone. So I will, when I was asked to say if I had an experience in textile, I've been working on textiles for inflatable structures in the past, and also in technical textiles for composite materials applications. So this is the one part of the story I will tell you about today. The company I work with is a CAPACITÉS, a subsidiary of the University of Nantes. I'm also a professor at the University of Nantes. And CAPACITÉS is at the crossroads of many topics, because we cover the expertise of many researchers and many engineers. Most of them come from PhD stories, and 90 collaborators, a lot of innovative projects. So we are at the leading edge of many topics. So actually, each expertise is let's say self-consistent, has its own projects, but more and more at the crossroads, let's say between medicine and composite, or between thermal applications and artificial intelligence, then we are able to gather some expertise and work together for a more complicated and coupled problem. So the outline of my presentation is this one. I will talk to you about 3D interlock composite characterization. Then we tried with a certain success, but not it was not obvious that optical fiber strain sensing is in this kind of material was really fruitful. And from this oxygen taken in the academic domain, we could leave some success stories I will tell you about at the end. So let's go. Interlock composites as 3D preforms have their success story by themselves with the LEAP engine for the new generation of planes because it's cost effective. Safran and Albany International set a joint venture to work together. Albany International to provide the preforms on the right, sorry, and Safran to manufacture the blades in the center and integrate that in the engines as the entry fan of the engines for Airbus or Boeing company. So the market is there now. Many hundreds of people are working every day to manufacture these blades, but this was a story which began like 20 years ago. So regarding the material I have here, it's a material which has been manufactured by Albany International. I didn't work directly with them, but I will show you at the end what the material looks like because I have a piece on my desk. So basically, the material is 5 millimeters thick, and you have warp and weft directions and an interlock toe in red here, which provides the assembly of all the plies in the warp and weft directions. And the advantage of this yarn is to increase the strength of the material out of the plane, so in the direction of the perpendicular to the plate. And it's a key issue in composite materials because with that you reduce delamination, so you are more robust and strong regarding impact, for example. And from the application of a fan at the entry of an engine, impact is really a key issue, like birds, like rocks and things like that, which can go through engines. So this is the architecture of my composite material. You see a kind of ugly microstructure, and I can tell you that the manufacture of the blades is much better achieved than the one that I did in 97, 98 at the University of Delaware. I was in a postdoc position, and then from there I could weave with the loom and figure out what were the problems coming from the manufacturing and how to cope with them, these defects or these specificities in the material. Then the issues are the process. First, the architecture of the preform, the strength in warp and weft directions, which we did on flat specimen. We investigated the strength out of the plane on L-shaped specimen, and we tried to instrument just to get some information back from the material and increase our knowledge on this material. So first of all, the 3D interlock preform is quite difficult to shape because all these plies are just maintained together by means of the interlock yarn. And if you want to make something else than a flat surface, then you have to enforce the plies to slide onto each other in order to avoid some wrinkles. Otherwise, if you have a wrinkle on the ply, it means that at that location, the ply has no more strength. And it can be a nightmare to invest so much in carbon parts and to miss the shaping of the material. And for this, it's one of the issues which will be at stake for any industry trying to use this material to do other things than flat panels. So back to the fundamentals of the process, because you will see later on that we try to investigate some issues on the process with optical fibers. The physics during manufacturing relies on chemical and thermal shrinkage. So basically, you have a mixing of fibers and resin. The resin comes from liquid state, roughly a density of 1.2, to a solid state with a density of 1.3. So something like between 5 and 7% of volume reduction. And this volume reduction will occur whatever you may do. You will have this shrinkage, and the resin will enforce the material to carry residual stresses. So the only equation we have here is that the stress state in the material comes from the C, the compliance matrix, multiplied by the strain tensor, and included in the game the thermal expansion alpha due to the thermal expansion, classical thermal expansion of the material, so the CTE, and the shrinkage coefficient CS versus alpha, which is the degree of cure of the material, of the resin. So taking that into account, we went deeper in the understanding of the process, and let me try to explain you this graph coming from the PhD of Yassir Nawab. Yassir was an exceptional PhD student. He defended his PhD in 2011, and now is the Dean of the Faculty of Engineering at Islamabad in Pakistan. And then you have a process from liquid state, the point A. You heat up your part, you let it cure, and you cool it down. So you go from A to B, from B to C, from C to D, D to E, and E to F. So back at the room temperature with a part which is solid. The woven, the sine curve represents the thickness of a specimen during curing. And the other curve, which looks like a sigmoid from 40 degrees up to 120, is the y-axis on the right. This is the degree of cure. So we come from 0 degree of cure A point to 100% degree of cure at the C point. So from A to B, the resin is liquid. You expand its volume because you heat it up. Then from B to C, you combine shrinkage and a variation in the thermal expansion coefficient of the material, because the coefficient of thermal expansion varies depending on the state of the material. So what I want to prove with this slide is that we have to really well know the behavior of the material, and not only know very well the behavior, but being able to characterize it, to put some numbers on that so that the industry can model the process, and with having the residual stress state on the specimen. Because for very demanding applications like aerospace, all this is modeled in finite element modeling in order to know if the specimen, if the blade, for example, contains a lot of residual stresses which may affect its behavior. Then you have chemical shrinkage, and we have to live with this physics in the material. So the process issues were like the difficulty to infuse the material, the need to control the architecture for curved structures, like stretching and forcing the plies to slide on top of each other, and shrinkage provides internal stresses. Next is what we did on mechanical properties characterization. So in the plane, the classical laminate theory is not sufficient because the DNA of the model that we applied in the next slides is based on the continuum damage mechanics. So basically on the curve that you have on the screen, strain at the x-axis and the stresses at the y-axis. When you increase the stress, at first you have E0, which is the classical linear elastic response of the material. And by increasing the stress, you will provide some micro cracking in the material. And if you remove the load, you will not come back to the origin of the strains. So this kind of behavior has to be taken into account in order to well represent the behavior and the stress distribution inside the material. So we have the ability to model the material. So on the left, you have a material which has been tested in the direction of the fibers. So the response is quite elastic and linear, and we go up to roughly 330 megapascal, which is not that high for carbon composite laminate, but this one is a 0-90 degrees stacking sequence, and the theoretical strength is reduced because of the interlock yarns. So on one side, you have a big increase in the properties, as what we will see in the next slides. But on this graph, it's a bit disappointing to see that the strength is not as big as that. In 45 degrees direction, which is the graph on the right, you have this particular behavior of damage, micro cracking, and permanent strains. So we have the ability to model that and to test this kind of behavior. And out of the plane, what we did was to try to understand how many interlock yarns we should have, which percentage of interlock yarns we should have in the part in order to optimize in a certain way this weaving. So we did a series of 4 specimens. The specimen with 1% interlock yarns has a series of yarns which were already woven in the material. And we played a game which was to remove some interlock yarns from the part and to manufacture the part after that in order to provide different ratios of out-of-plane yarns, just to check what was the influence of the number of yarns across the thickness of the specimen. Then at that time we developed a test, and we are quite familiar now with developing tests for customers, because many customers now come with a new idea, a new test to achieve, and we can both cut the specimens, design the test, and practice the test. So this is basically the load displacement curve that we have by unfolding the specimen, which have a L shape. And coming back to the interlock yarn ratio, 0.25 up to 1%, then the strength in megapascal can go from a bit below 200 megapascal up to more than 300. It means that we were expecting in the in-plane test a strength which was around 350 megapascal, and by curving the specimen, because we have these interlock yarns, we keep a quite high level of stress above 300 with 1% of yarns, which is quite satisfactory, because with no yarns, we would be far below 200 megapascal, which means that we reduce the strength of the specimen by something like 30 to 50%, just because it's a laminate, and the criterion for the failure is not the same anymore, because you will have a delamination between the plies. Then, change the slide. In further works, we will expand. We have already expanded our testing capabilities by testing devices like the one you see on the screen, using digital image correlation to have strain fields instead of stresses measured by strain gauges, for example. We use extensively optical fibers strain sensing when it's necessary. And we add everything with finite element calculations in the nonlinear range to have a discussion between experiments and modeling. Now I'm turning towards optical fiber strain sensing. So this strain sensing comes from, you see the pen there, the pencil, and you see the optical fiber, which is a tiny glassy stick, and the sensitive part is like 10 microns inside the glass coating of the optical fiber, which is 125 microns. And in addition, you have a plastic coating, and the final diameter is 250 microns. And on this graph, you see a line at 45 degrees from the horizontal, and this is the optical fiber embedded in the material. So this optical fiber was a big promise to be able to go inside the material and check some properties. But we ran many tests just to figure out if what we were measuring was true or not. So we embedded some optical fibers across the thickness, perpendicularly or at 45 degrees. And the surprise is to measure between the liquid state and the solid state deformations, strains, up to minus 3,000 microstrains. So it means that we have 0.3% of thickness reduction measured by the optical fibers. And this was quite a big surprise. Now we are not surprised anymore because we master that. We are familiar with this shrinkage phenomenon, but optical fibers can be a good information to check inside the material, but the cost to pay is very, very expensive in terms of time of broken fibers. So it's only an academic action, and I wouldn't sell it from scratch on any applications in the industry. But if necessary, we can do this kind of thing. Then we investigated the sensor by itself by submitting the sensor to a kind of a strain gradient. You have there just a tensile coupon from the PhD of Pierre-Antoine Morvan. And this coupon has a fiber rack grating just in the middle, in between two materials. It's like if we were trying to put the optical fiber in a non-homogeneous strain field, like the one which would be the in interlock yarns, interlock preforms, for example. Because when you have a periodic tow and resin architecture, if you put this fiber rack grating inside this periodic architecture, then you will have something like an average of the response, and this is not really what you want to get from. So on the right, we have a specific reflectometer measurement. So it's very, very heavy experiment, big interferometers, and this cannot be used in the industry. And from this specific instrumentation, we could prove that when you go from the soft material on the left towards the stiff material on the right, then the strains which are normally plotted as the smooth lines in the theory are not smooth anymore in the experiments. So you suffer from many gradients, many disturbances in the strain field. And it means that people who measure with fiber bright gratings inside technical textile preform should pay attention to the validity of their measurements. Otherwise, they will just say something wrong. And we proved in the PhD of Pierre-Antoine Morvan that the error could be up to 30%. So it's not satisfactory for let's say to use this instrumentation technique to assess strain field in materials like this one. Okay, so from these academic studies, the key is to understand the mechanical behavior of composite materials or the manufacturing, like handling. So still the preform is like something which cannot really be automated because as the first speaker said, you have many defects, and these defects can directly have an action on the strength of the material. We have to cope with physics like shrinkage. The instrumentation is possible, but with limitation, as what I said on optical fibers. But in any case, these academic studies were like oxygen to provide expertise towards the industry at CAPACITÉS. Then I go to the applications and the success stories now. So first, we were challenged by New Zealand syndicate for the America's Cup in 2010, between 2010 and 2012, because I was involved in the development of the platform by putting some optical fibers almost everywhere on the boat to monitor the hull, the rigging, the mast, the appendages like the hydrofoils. And they were really happy to gain knowledge and to be able by themselves after that to instrument their boats. Second success story is the very recent development on solid sails by Chantiers de l'Atlantique in France, here in Saint-Nazaire, near Nantes. These sails will be put in cruise ships within the 2 or 3 next years. Here you have a mast, which is like a mock-up of the rigging, which is 15 meters high, and we put some optical fibers in there and also some strain gauges. But the next generation at the scale 1 will be a mast of 80 meters high and a sail which will be 1,200 square meters. So this will be just huge. And we are accompanying Chantiers de l'Atlantique in the monitoring of their structures. This is a drone with 2 wings, and the wings are equipped with solar cells. And then the company Ixon put on top of our exchanges a PhD on to assess the fatigue of the structure from an electrical point of view. It means that the solar cells may suffer from mechanical fatigue. So this is what we are investigating actually. And in addition, on this slide, we are just calibrating the response of an optical fiber, which is embedded in the wings. This is a bending test, basically, that you have on the picture at the bottom. And the fibers are not there to monitor in real time the drone, but to check, like a non-destructive evaluation, if the plane suffered from an impact during the last 10 flights, for example. So it's quite interesting because the optical fiber is very light. It's inside the material, like the testimony of what could happen. And in case there is a shock, then this sensitive, this sensor can testify that the impact has an impact on the damage of the wing. And last one, which is ongoing, is the use of fiber brag gratings inside helicopter blades to monitor then in real time the state of the blade in order to provide to the pilot the information if he can save the helicopter by finding a nice place to land, or if he has to save his own life by making a crash stop. So the issue between these two scenarios is just the price of the helicopter, around 12 million euros. So this is it. Thanks for your attention, and I will be happy to answer your question if any.
Sorry, I was muted. I was thanking you for this nice overview that you provided. So I have some question I have one question for each of the speakers. So maybe we can start by you, Pascal. What are the future trends in miniaturizing sensors to be used with optical fibers? Are there any approach to make them viable in industrial use?
Yeah, we have many things coming from 3D printing specifically. Now, this topic of 3D printing on anything, and especially in the domain of textile and technical textile, will provide the ability to put some very small sensors where we need to, and we are working on that besides. So how to use 3D printing to provide and to print directly some sensors inside the parts, and then to infuse with resin and have the part which is like intelligent by embedding some this new generation of sensors.
Thank you. And Gilberto, if you can open your welcome, there were a question as well for you. Beyond circular knitting, could the system be applied to other knitting weaving systems? How much saving in percentage have you estimated for the textile companies on having the Smartex system versus not compared to not having them?
Yeah, great question. So the system was designed in his hardware and software to be suitable for any roll-to-roll production. We don't need to be just in the textile industry. Like there are other interesting places like plastics, papers, thin films, you name it. However, the textile industry for now is the most interesting because is where the pain is definitely huge, and the average saving that we see in a circular knitting machine for like normal production, let's say cotton, single jersey, like normal sportswear production, it is around $1,000 per month per machine. Of course, if the clients are producing very expensive yarns or very thin yarns, all of these multiplies by the respective multiplier of price of the yarn and the price of the raw material. For weaving, things are not that different, okay? Despite the weaving machine produces like 5 times slower than the knitting machine, the prices of weaving of woven fabrics is typically 5 times higher of the comparing with the knittings. So if you do the math for 1 hour of defective production in the knitting machine and 1 hour of defective production in a weaving machine, financially is similar, despite the amount of fabrics is way different. But financially, impact is very similar. There is another point, an additional point here, which is textile industry is always very dependent on human intervention, like human inspection, human activities with the yarns. The humans will change the needles. The humans will are going to do everything inside a textile factory. That's not a trend to stay. I can imagine the industry in 10 or 20 years from now, fully automated, very independent from human intervention. We can start imagining some sort of textile factories in Boston, in big cities. We don't need to run away from cheap labor countries, because you start seeing in the horizon, you start seeing automated robots to handle with fabrics for the confection, the sewing part, or robots to put the yarns and the cones in the place for the knitting machine. You start seeing circular knitting machines with electronic needle selection, so we don't need to have like those people to go there to the needles and put the needles in the correct positions. So you start smelling these types of automation. You already have it in other industries, and definitely computer vision is part of all of the other industries, and textile won't be different. You can imagine the factory of the future in textiles will be fully optimized for and automated with cameras everywhere, cameras in every place for every checkpoint connecting the industry from one point to the other. And when you buy a t-shirt in such a website or wherever, you can just put some orders and digital orders directly for the yarn spinning machine that will be connected to your order, and then we will jump the yarn for the kneading, that will jump the fabrics for the dyeing stage, and all of these could be fully integrated and fully traceable with computer visions, for example. But yeah, in simple ways, the financial impact in the weaving and knitting are very similar. 1K per month average numbers, rough numbers.
And our reaction regarding to that, the 1K saving is after the monthly fee for the system. But
can
maybe
you, repeat,
you can, a question to confirm, the 1K saving is after the monthly fee for the system?
Yeah, the monthly fee is way lower compared with the savings. For example, one average client that we have, for example, in Turkey, they have 200 knitting machines. So if they save $1,000 per machine per month, you do the math, the impact is huge. And it's not the case that these folks, they are wasting 1,000 euros per month every month. They are not wasting. What will change is that they will buy less yarn and they will buy less raw material to produce the same output, because they will eliminate scrap rate. So the math will make sense for them because they will buy less to produce the same.
Thank you very much, Gilberto, for this precision. Is there any other question you can write in the chat? Looking, but I don't see other question coming. Well, so I would like to thank you both, Pascal, Gilberto, for your inspirational success story and your presentation. If the audience want to raise some question, you can still write in the chat. I think our speaker will be available to exchange during the virtual marketplace as well. Thank you, Pascal. Thank you, Gilberto. I suggest to continue with the textile companies. So we will continue with Rui Sousa from Somelos, who will present Somelos IT perspective. Rui, are you here?
Yes, I'm hearing. Turn on the camera. Good morning.
Good morning. So we will appoint you as a presenter so you can show your slides.
Okay. Screen. Okay.
Yeah, just
Share. I don't know if it's okay.
so far, yeah. So you need to put it perfect. That's it. We can hear you. We can see your slide. The floor is yours. Thank you.
Thank you. Somelos is a woven fabrics producer, so our problems usually are in some of the points that have been indicated by our colleagues. Usually we have our orders. We are already making a grouping of orders, so we improve our efficiency within our company, because we have small batches of product, so we have to improve the efficiency, if or else we would be always stopped and making setup within our machines. Usually we group the orders from our clients within larger groups, so we improve efficiency. And then we have already a Gantt chart where we can calculate our deadline to the customer to see if we can achieve what the customer wants. If not, what is the best deadline that we can make. We already have some efficiency issues that we are optimizing within this Gantt chart within a human relation with the rules. We are trying to have the best setup when we make the order within a machine. This setup, this Gantt chart gives us an idea if our production is up to date or delayed already. So the operator, the user, can make small changes in our production, so it can achieve the deadlines that the client wants. Or if a client has some urgent demand, we'll try to embed it within our production orders. Within our company, we have some contamination issues. Sometimes we have some dark fabrics and some light fabrics, or some clear, some colors that influence the other colors within the weaving, the shop floor. So usually we have a concern trying to avoid that these different types of products are mixed within the same machines or near machines, so we don't have some quality issues in the end of the production. Within our shop floor, we have an infrastructure and have some IoT, some sensors that give us the information if our machine is stopped, is working, and some of the automatic causes of stops within the machine are already gathered within our system. If the machine stops for another reason, the operator is able to interact within our electronic device and say to the system why it is stopped. If he's doing setup, if he's cleaning the machine, if the machine is stopped because it has a malfunction, it's already gathered within our IT system. So we now already have a connection or relation between our planning and our production. And this way, if something happens that will delay our production, the planner has a chance to improve our efficiency and reacting as early as possible. We are developing a new system with HATA, that's a company of our group, so we can have the information gathered with system and this interaction made by some other kind of electronic devices that are not only the ones within the machine, that are very limited with the interaction. This way we can have a person that has a group of looms and he can see what's the problem with the looms and avoid that walking around to see if the looms are or aren't working. This way he has the information within his range, even if he's far away from the machine that has a problem. He can see the efficiency of the machine as so he can react to be more attentive or more within the machine, so to understand why it isn't working as it should, and he can define the orders that we are producing and the next one, so we can see when it is going to end from the point of view of the production. This information, we already have it. We are developing this product, so we can have this in all the machines in the company. Now we only have it in looms. We are changing it and upgrading it to the rest of the company. From this information, we can have the overall equipment efficiency. We have a view from the machine, the group of machines, the product. We can have several statistics that we can see to improve our efficiency, to analyze what is the main cause or main reason of our inefficiency, and what we are losing with this inefficiency, and how we can regain this efficiency within the company. We are also making a project of an ID project with HATA, CITEV, Min University and CCG to try to improve our planning within some artificial intelligence and operation research, mixing the two within a module that can suggest some new changes within our production, some sceneries, so we can improve the efficiency. Because as I said earlier, the human has some tools to improve efficiency, but when all things start to happen, when a client demands or asks for an urgency, when some machine has a breakdown, and so or the efficiency isn't what it is expected to be, sometimes that decision that he made now isn't optimum. So we within this we'll try to analyze the production, actually the charge within the production that is being made, and suggest new sceneries, new hypotheses, so we can change and improve our efficiency within the company. Okay, and this for now is our expectancy for the next couple of years, which I think it's already a bit heavy. Thank you.
Thank you, Rui. We will continue with Jorge Matex from Belda Lawrence, and maybe after that we will have a short interaction after the three company presentations. So Jorge, the floor is yours.
Okay. Good morning. You see the screen?
Yes, perfect.
Okay. Thank you, Lucia. Good morning and hello. My name is Jorge Matais. I'm representing the company Belda Llorens, which is a spinning company specialized on recycled yarns here in Valencia. Well, I'm here today to try to make a picture of how is today our local industry, but not only on the spinning in general, and how we could translate from the current situation going to the industry 4.0 and digitalization. To start, I would like to talk about what are the main characteristics of our local industry right now, but not only, as I said before, in the spinning, but also in the rest of the textile industry, including knitters, weavers, and finishers. As you can imagine here, most of the textile industry in our area, it's composed by small and medium sizes companies. Many companies has a very long tradition, and many of them second and third, the owners are the second and third generations, which give us a big know-how of the industry. Basically, after the globalization, which started in more or less in 2008, many of our companies went out of business. But we can assure that today, the majority of the companies are in a very good shape and very healthy. Even though we can assure that from the technical point of view, we have our park very updated, but still looking for a new high-tech solution. During the last years, in order to compete with imported textile products, we have focused on research and development, especially in the product, having a high differentiation. This has been a must for our companies in order to survive. We have also have the support of associations as HATA and ITEX, which have helped our companies to invest on research and development. Also, we have been applying in our plants and new models of management as the lean manufacturing. Our ERP systems has been updated to the latest version. Internationalization is one of the main characteristics of the Valencia region, not only textiles, but also other industries. We have we are very strong on this: ceramic, furniture, shoes, agriculture. Also, another characteristic very related to the next one, it's is that most of our plants and the roofs of our plants are covered by solar panels, and we are using clean energy in this moment. And let me tell you that today, sustainability and circular economy is one of strong points that of our industry here. And I would like to get a little bit deeper on this. Today, digitalization and circular economy are very popular subjects. The European community is applying a considerable amount of money to research and development on both. As a representative of Belda Lorenz and being part of one of our main characteristics of our local textile industry, I would like to get deeper on sustainability and circular economy. But I think it's very important to share this information. 5.2% of the worldwide textile waste is coming from the textile industry, and 50% of the clothes are only recycled or donated. The rest is going to the landfill, which is a huge problem. Our region is the largest producer in the world on recycled cotton, coming from the scrap collected from the confections. But not only that, besides we using recycled cotton, we also practice the reuse of our internal waste. This is really normal. Post-consumer fibers as polyesters, and the continuous investment and development on sustainable fibers as recycled viscose, biodegradable fibers, fibers coming from biomass. Those are the ones coming next. And there is also a big investments coming into new textiles recycling plants, which these plants will be able to use post-consumer garments and exits of stocks of the big brands, and being able to separate bottom slippers and separating the fibers and reusing again, and to really practice a real circular economy. I really advise that this is going to be very interesting and very surprised. Many things that are coming very soon. On this slide, I want to show you what will be, for example, the savings in terms of a new cotton growth or water or emissions of CO2 of energy of my company, Belda Llorens, in the whole year of 2019. As you can see, the numbers are really significant. On this picture, also, I would like to show you how 2 yarns made by Belda Llorens out of recycled cotton and recycled polyester, comparing with conventional cotton or even organic cotton, what is the savings on water in 1,000 kilos of yarn. And to finalize on this sustainability and circular economy, I really consider that in order to consider a company involved on sustainability, there are 4 premises really important. One of them is to really show and measure the environmental impact of the company. I mean, the footprint in the planet of the company. Also to research and develop on new sustainable materials, always focusing on what is going next. Transparency means that a third party should certify the traceability of the fibers and the whole supply chains. The GRA certification is something to take in consideration. And at the end, I think that communication is also something crucial. We should be able to communicate to the final customer all this traceability and all these parameters. Marketing is crucial also on this. And this is my company, Belda Llorens, and it's 65 years, more than 65 years, working with these recycled fibers and investing on new ones. And we have a really big know-how on spinning. Belda Llorens and the brand Ecolife, it's a referent today in the world of sustainability and circular economy. And once we have seen already what is more or less the parameters and the characteristics of our local industry, I would like to talk a little bit what will be the challenge and the opportunities in our industry on the different sections or departments of the companies in order introducing the digitalization and in the industry 4.0. On planification, I think that the digitalization will allow our companies to reduce the stocks of all supply products, since raw materials, spare parts, office materials, and everything. Also, to have online and current information of production planification and programmation will allow us to follow orders online and any delays or advanced production, just what we have seen before with Somelos. Regarding production, to have a visual control of the production process, or even to be able to predict maintenance of the machines, again, avoiding big stocks of spare parts, especially electronic ones, which are really expensive. In the spinning, and even much more here, that we produce very small lots due to the fact that we produce colors. Shifts is one of the major costs of our production. And to be able to control by digitalization of these shifts will reduce the cost significantly. We also, in our companies, are applying quality control as the ANFE. ANFE is a system, a method coming from the lean manufacturing. To have a digital and visual control of the defects of the product during the production process will revert also into major quality of the product. From the logistic part, we will be able to have a just-in-time in the whole internal process and external supply chains. That will be fantastic. Also, we will be able to interact with the transport company to optimize the load and unload of the goods. To collect a big data of statistics per color, per sizes, per content, per seasons, per tendencies will bring us to a perfect management of our stocks. From the commercial and the sales part, we still in our industry, especially in the spinning, show our color cards and the samples in a physical form. To get digitalization on this will save a lot of material that we spend on this subject. Also, digitalization will not only avoid this material, but also will allow our customers to have a final product simulation by mixing colors. Anything could be done here. We still now currently we take time to answer orders, even if we offer a stock service. But the possibility of sell online and inform of the change to the customer on a real time will be very, very helpful for our customers. From the general manager point of view, digitalization will allow to the general managers and also the managers of any department to have a general view of the main parameters of the company in a single screen, online and updated. I just can imagine having different visual dashboards with instant and updated information of the different departments. And to finalize, this will be a little bit some of the consequences and the benefits of establishing digitalization in our companies. Much better and fluid information, major efficiency and productivity of the plant, decrease significantly the stocks levels of all types of materials, improve quality of the product, reducing claims, much more customer satisfactions and service, reduce direct and indirect cost of the product, and optimize human resources. I think, and I really hope that we are really close to this, as we have seen in some of the others' presentation. Our industry really needs this very, very fast. Thank you very much for your attention, and good morning.
Thank you very much, Jorge, for this very interesting presentation regarding the needs for the textile industry. We will continue with Jordi Mota from ISIMA, and then after that we will maybe take some question if there is any from the audience.
Okay, thank you, Luisa. Can you hear me?
Yes, I can see your screen, but maybe if you can pass your presentation full screen, that would be better for the...
Okay. Can you see my screen?
Not yet me personally, but
no?
I can see your screen, but not full screen.
Okay, let me try to share another time. Maybe now?
Yeah, that's it.
Yeah, okay.
Thank you.
Okay, thank you, Luisa. Good morning, everyone. My name is Jordi Mota. I am the R&D manager at ISIMA. Yes, in this presentation, we will see, first of all, a little presentation of our company, and then just the first steps that we have done in terms of sensorization in our knitting and finishing plants to increase the productivity, the quality, and sustainability. And just to see what we have done in the first steps to our idea to transform to a industry 4.0. So yeah. Yes, in this first slide we can see a little summary of our history. but maybe the most important thing is that you have to know that at the beginning, ISIMA was a small knitting company focused on garment and home interior markets. And by sure, the most important movement of the company, it's in 1998 when we had at our knitting company 22 dual racial machines. Because at this moment it was the change of the main business of the company, and it's the main business that we have now, because we started to produce 3D spacers, and yes, now it's the biggest product that we supply to the different markets that we will see. Just to see where we are located and so on, and we have two main facilities: the sales office and also the dyeing and finishing plant that is located in Sabadell, and then the knitting plant that is located in Terrassa. Terrassa and Sabadell, there are a very well-known cities with a large tradition in textile industry. Now we are less companies, of course, but yes, some years ago it was they was the one of the biggest cities in Catalonia and also in Spain working in the textile industry. And yes, you can see that now we are more or less 110 people working in both facilities. We produce 5 million of meters, and yes, we are very near to to Barcelona, less than 20 kilometers. We are not a full vertical company because we don't produce yarn, but yes, we buy the yarn, and we have a possibility to work the yarn with two split warpers, mainly for the monofilament of the 3D spaces that we produce, and also we have one direct warper for the other beams that we have to do. Then in terms of the knitting process, now these numbers, I think it's from the last week, so I suppose that are well updated. Now we have 23 single bed kettle machines, 5 single bed racial machines, 40 double bed racial machines, 1 circular and 1 jacquard circular, and also external machinery that are also producing more circular fabrics, and 2 weft knitting machines. Regarding the dyeing, finishing, and coating, we have 18 brushing, 7 shearing machines, 2 piecing machines, and they are disposed in different lines because depending on the product that we have to treat. And in terms of dyeing, and we have 17 jets, 5 autoclaves. Also, we have 3 padding, 1 rotary screen coating, okay, and 3 stenters, to do the complete finishing process. And finally, we have also 1 transfer printing calendar for some printing that we develop. Also 1 lamination calendar for laminate some membranes and so on, and 1 rotary nib cutting to cut the pieces at different widths, and also 1 laser cutting machine for some specific references that our customer needs, specific pieces and sizes, okay, and shapes. The markets that we are working on with, well, maybe one of the most important could be the orthopedic. In some cases, we work directly with the final customer from orthopedic market, and in some cases, we work for an intermediate that we supply only the fabric that they have to transform. Then automotive, industrial fabrics, shoes, upholstery also regarded to the as you can see in the picture, office chair, lingerie, mattresses, and technical garment. here in technical garment, we can speak about maybe some parts of jackets and so on for for defense or personal protective equipment and so on. But we put in the same sector as technical garment. Okay, we produce, well, we export more than 70% of our production. 57% is from the European Union and 15% is rest of the world. And at national level, we work about 28%. Now we are working with more than 38 countries around the world, and this is one of the reasons, because in past financial crisis we will kept a little bit not in the best numbers in terms of economics, but we will still here working. This slide is just to summarize or to understand that yes, we think, or we thought that some years ago, and we are still thinking that it's important to be or to have good partners to work. And we are membership of AI Textiles, of SECOT, Texfor, and Instituto Industrial de Terrassa. We are certified, of course, by with the ISO 9001, and we have the level of global recycled standard and also the OCOTEX. And we work together in projects and in testing with several technological centers, but mainly LATAT and ITEX. Okay, and now next slide is just to explain how have we done in let me say the transformation to Industry 4.0. Because yes, some years ago we were more focused on do research in materials and improve materials, and and put new machines to get better, and try to found different chemicals and coatings to improve the materials that we develop. But more or less 3 years ago, we have an internal meeting with direction, and we decide to not only focus on develop better materials. Of course, we have to develop better materials, but also to be to be a better company in terms of efficiency and control, transparency and sustainability. And this is why we decide to try to move Industry 4.0. So talking with our colleagues from IAE, they propose us to do a consultancy to see what was our state level in this material, and we contact with consultancy that they were at our facilities several days, maybe 2 or 3 days, I think. They was observing our processes and talking with us, and they could prepare this map. This map is let me say it's a model of digital maturity for the Industry 4.0, and you can see in the different axes, so the digital adoption level of the company, and also the enablers for the transformation to that industry. So we selected different processes or areas from the company to be to focus our real estate, and we divided in smart product or services, and the collaborative supply chain, the smart factory, the customer relationship, the smart management, and finally you can see the weight average of these processes. So as we see that we are at the entrance zone or the beginning zone, but with good skills for the transformation. And yes, and maybe we are near to update to date in terms of the digital adoption level. This was important because yes, as we can see that we were with very updating technologies. We had yes a good skills to be or for this transformation. But after go on, we decided to focus in the main or in the most important areas and doing the roadmap to this industry. So this was important because talking with the consultancy, it's important to define a roadmap because it's it's very difficult to understand, not to understand what we want because more or less the company knows what we want, but it's difficult to plan what we have to do to move from the entrant zone to the transform zone. So yes, the little circles that you can see, it's only to show that we have to do little steps to get the transformation, and it's not the best way to try to go in a faster way. So we have to do little steps to go to the transformed zone. So our company, we had already a ERP. It was available from several years ago, and it's a good ERP, and we have implemented very interesting models. And then we have some PLC in the most new machines, but not in the older machines. So the first step that we performed was put or install PLCs on the knitting and the dyeing and finishing plants. Yes, and then, for example, in the introduction, in the PLC introduced at the knitting plant, it was the installation of PLC just to see how the machine is, or if the machine is working and not, and if it's stopped, why it's stopped. And then also we try to introduce some sensorization on the dye and finishing plant that we will see on next slides. Yes, this sensorization, yes, we started on the one of our standards. So just to see in line, for example, the weight control, and then with the PLC and the the automatization that we can perform is adjust the overfeed and the speed and the squeeze of the machine. Also a temperature sensor inside the different chambers or cabins of the standard to see the real temperature of the fabric and to do a better drying and thermosetting, not just for the thermosetting of textiles, but also for the polymerization of some products from the finishing or from the padding. So this also permits to adjust the speed of the fabric to get the real time that you need. Also, we introduce a residual moisture sensor at the end of the standard, because for some, as you know, for some processes or post processes, you need a specific humidity and relative humidity. So we can adjust the speed to get this humidity, and also the exhaust type moisture, because yes, normally you have the fan speed and the flap open, and then you are put inside the standard more hot air to dry the fabric that you need. So with this sensor, we know if the air that we are exhausting it has moisture or not, and then yes, it's the best option that we have to get a better sustainable or more efficient energy efficiency system in the standard. So yeah, and the actions that we perform, it has some benefits. Yes, now we have all the key data at a glance. So you can see all the key data inline and also online, because we can collect this data and see from other system. Then it reduces the decision time. So now we are more flexible and more faster than some years ago. It permits to have full control of the batches and also the full control of the key process parameters. Maybe I highlighted three of the most important from my point of view. Is it provides an improvement of customer confidence because of the quality control, also an improvement of productivity and the quality and sustainability, and also the improvement of company worker satisfaction. Our workers are more satisfied than some time ago, because they can see that their work has more sense and where to focus to do a better job. Yes, this is that we perform, but in the future implementation, we are on the way. We want to improve the machine learning to avoid the defects. Also, yes, use the machine learning to make the planning proposal and adjustment because of the undesired stops, and implement the machine learning for planning the machinery maintenance. This is something that it's this last one is really easy. That it's something that we will do in next months. And yes, the next step will be collect all data. Now it's collected, but we have to integrate them on a MES or on other system, because now we can see the data, and we can do some automatic process with the data that we collect, but just per each machine. And now that we want to implement, it's that collect that data to have another system to control in all the plan, the knitting and the finishing plan, from the same software. And also in this sense, make a new dashboard for the production controllers and also for the workers to see all the process in our companies. Yes, from our office. And finally, I want to do just a last slide to talk about the future challenge from our point of view. I'm not talking about the industry. It's just for our company. Yes, we are trying to improve the defect detection at knitting plan. We do some approaches with some different softwares and technologies. Now we are not. Yes, the defect system explorers don't sufficiently solve our problem because of the investment that we need and take it into account the return. This is, I think, is a particular circumstance here from our company. Maybe with the solution that Gilberto shown before, maybe we can go on. Also, another important or future challenge will be the automatic warped beams warehouse. This is something that it's solved, but we have to see how to implement in our plan. This is for the storage and transport to the machines. And finally, we want to see maybe next week on the panels, we will see how robotics can help us. Of course, one of the most important problems in our industry is the change of the beams and how to prepare the machine, the yarns, and so on. It could be very interesting that someone's develop a solution. And also the use, this is also solved, but the use of the automatic setup of the direct warpers due robots. This is something that it's possible, but we are now just seeing if it can help or not us. Okay, thank you. yes, this is me after the pandemic, after the first lockdown. Now I have no hair, but yes, thank you very much. And if you have any question, of course, I will be glad to answer you.
Thank you very much, Jordi. Actually, considering the timing, I'm suggesting for all the audience to write their question in the chat, and do not hesitate to use the bit to match functionality as well to get in touch and write messages. And we will continue now with Seribaz, with Patrick Cadamon and Dominique Bedway. Thank you for once again for the three speakers in the Textile Future Challenge that presented, I think, very interesting elements, and we will look for the next session. Dominique, Pascal, Patrick, pardon.
Hello, do you hear me?
Yes.
Hello, do you hear me? Yes, good. Okay,
Yes.
and I get. Okay.
Hello.
Hello, Dominique. Hello, Patrick.
Okay. So do you? Yes.
Yes.
Do you have my screen?
Just full screen.
So is it okay?
Yes, and if you want to open your webcam, or that's okay as well. The floor is yours.
About the webcam. Okay. Have you the picture? Well, have you the slides? It's most important than the webcam.
Yes, I think. Yeah, the slide, you can put it full screen.
Okay, then you have the main page, the front page. So good morning, everyone. My name is Patrick Caldamoni. I'm working at Seribase, and I am working at the R&D service and work actually on several projects that are well, I am involved on a collaborative and several projects having a smart textile facing smart textile. Sorry. Well, we'll try to do smart textile. I will present at first. Well, you see, it's very original presentation. I will go with a company overview and what we are good at Seribase. And then we'll discuss, I will present and show sensors in different activities and customer cases. And actually, it's more about sensors involved in the IoT, so the Internet of Things. So it's not about machines, but more about products. So a few dates. The company Seribase was created in 2002, but the people who created Seribase were working since the beginning of the 80s. So right now we have a 40 years old know-how and background. In 2011, Seribase starts the AFILIM, which is the French Association or Groupement of the Industries in the Printing Electronic field. And that gathers major French companies and startups as well. In 2014, another important date is when Seribase became a part of the group. Previously, it was working on itself, and now Seribase is member of the Ambitio group. And one of the first action of the group was to reinforce the R&D department, which was very important for the strategic plan. And now in 2021, even if we are 35 persons, you can see that the group, the R&D service, is composed of 8 persons with new competencies involving AI solutions, software development, or software smartphone application development, and of course sensor developments. So what are we good at Seribase? We have mainly 3 fields which are based on the ink and substrates, the printing process, and then the functionality. In the ink and substrates field, we are facing the reality, which is that there is a large range of particles. If you want to print and if you want to print circuit, you have a large choice between silver, graphene, P.PSS, conductive inks, or dielectric inks. You also have to face their properties, and you have to print them on a substrate. And then the substrate, the number of substrate is quite large as well. We print on paper, textile, films like PET or polycarbonates. And the thickness, after you have the right substrate, the thickness is another problem, or another thing to be good at, because you don't print on a 5 micrometer thick substrate as you print on a 250 micrometer thick substrate. So the technical printing are different beyond the substrate and the nature of particles. So we need also to be good on the printing process, and we have chosen at Cerebase the silk screen printing process, which is quite versatile because it enables to print a wide variety of inks on a wide variety of substrates, and it enables also to work on small batches, large batches, and small parts, large parts. All the customers in the IoT field want specific parts with sensors on specific substrate in relation with their market. So we have to be good on the printing process. And at the end, more recently, it's about the functionality. The functionality, because first we were just printer. We printed just inks on substrate. But now the customer needs more help and more background and more support. He wants the full functionality. So just printing a sensor is not enough. We have to be good on the treatment, the measurement, and we propose also the customer's application and the end user in relation with the end user needs. So all those three fields are our fields of expertise, and we propose them in daily activities in three different main activities, which are the human-machine interface, very industrial, the lighting, more in the aesthetical and perfumery field or luxury field, and the last one field is the customized development, which are not only product but not sub-assemble of products but whole product. And then we will see what kind of sensors we place and we do. First, in the human-machine interfaces, the very first sensor are just the detectors, the basic on-off key, but we have now new aims facing the translucency or the activation force or no force at all. So the customer have new needs, but the key, the classical key, is a sensor or detector. We have also capacitive resistive sensors like a smartphone. So when you just touch it with the finger, you can detect something. But if you approach, if you are not touching, if you are contactless, you also are able to have a measurement. We also can place classical SMD chip sensors on the printed circuit, and more recently the piezoelectric sensor printed with new inks are arriving for vibration or heat detection. So all those sensors are used actually in the industry. In the lighting, we have a different nature of light, the LED, of course, or the electroluminescent, which is a printed ink that brights or that give lights. We need sensors to control the energy. For some customers wants to have a flashing mode, dimming mode, Some other wants to switch on the light in relation with the sun light. If the night starts, then we enlight the product. And in the few years, we were also working on the energy harvesting, then using the radio frequency signals energy to get the energy, sufficient energy to enlight or to switch on the LEDs. So on the picture with in the bottom right corner, you have a car. The LEDs printed on and implemented on paper circuits are get the energy from the mobile phone that you can see on the very hand right corner on the bottom side. And the mobile phone is placed on the NFC mode. The energy is coming through the NFC mode through the antenna printed, which is a sensor, and given to the LEDs of the car. So sensors are basically everywhere. And in the last part for the customized development, we go with our customers from just sensor single part, just the sheet with sensors, electrodes, up to the full solution, which are complete product with information to let the customer decide how we can do the improvement. So just in details, the sensors, detectors, or electrode here are shown to let you understand that printing a track with appropriate ink can have different functionality for the end user. On the left-hand side, we have an intrusion mesh detector. This is a flat, a foil with one track covering the whole area. And when the intruder try to go through that kind of skin, it will crack a track, and then we detect the intrusion. With the same process, other inks, we cannot do soil warming circuit, and that's interesting because soil is in the textile and wearable market. Soil pressure cells, you can see the black dots, which are the top of the cells, pressure cells. And here we're also again in the textile and wearable field, and some other products which can have interesting opportunities, like the electrodes. In this picture, we can see the electrode used for the COVID-19 PCR analysis. Open market as we work on biocompatibility aspect, and this is interesting also in the wearable and textile field to have sensors in touch or in contact with the skin. On the sensors, products with sensors for the improvement, performance improvement, the customers may need a product with lot of sensors. Here we have a picture of the Smart Mart, and here Smart Soles. And those products need not one sensor, but a lot of sensors that will react or act like pixels. Then just for us, from our side, printing cells or sensors 1 or 10 or 100 on sheet is not really a problem. The problem is not anymore the sensor, it's more about the information, how to get it, how to forward the real value to the customer, and how to let the system interact with the end user. So this is the reason on the left-hand side, you can see a lot of cells, just person walking on the mat, and with the dashboard or just a software, you can interact with the end user. In that case, you just have two solutions. you inform him that he can go or not. On the right hand side, you have soles. So the difference is then you are in an embedded electronic, and there is mobility with this system. And this is the same thing. You have a lot of cells printed at the same time. It's not problem, but the whole cells in real time giving information at almost the same time is more difficult. Then you need to have electronic placed very close from the sensor. And after you go with the wireless system to forward the data to the user. And those systems in the wearable field are used for the teaching, because it's very difficult for teacher to see how the student is on his feet, if he's doing the right step or he's having the right position. With that kind of system, you understand that in real time, you know how the person is placed on the soles. And you understand also that those systems need dashboards or a system with graphical charts. Another product now with the printed sensor is the Somelos item. It is a sensor that detects water or humidity, and while all those sensors may be transferred to textile, as we print also on textile and we work with textile, but here it is placed on the roof, underneath under the roof shield, and the object is to detect if the roof is waterproof or if there's a leak. So there's not only one sensor, there are many sensors all over the roof, and the sensor needs to detect the presence of water or not, but it needs also to communicate the information. And then because we have plenty of sensors on the roof, you need to have a system that makes the data collect. So there's a box, and the box needs to be needs to have a configuration mode and transfer data in real time, maybe to a server or cloud or computer, something that will collect data and let the software with the appropriate application give the right information to the customer or the end user. Of course, you understand that now just a sensor, and we have seen that in the previous presentation with the machine or the charts, the Gantt chart. Having sensor for the automation or the performance improvement is not enough. It's sensor plus the graphical chart. So when I was requested for the presentation, and this is the conclusion, the performance improvement, in my mind, it was like the dimming cycle. It means you need to plan, do, check, and act. That I guess everyone here knows. And if we transfer that to the sensor and the system printed on textile or on soft films, it needs to have a system configuration. So software, when you place the alert levels, you decide what you want. But of course, sensors printed or implemented on the appropriate substrate, as I said, PET, textile, paper, or other substrates. Then the sensor is working, it gets the data, so there's electronic to collect data and transfer them to the server, and the human action or the just automation to react. And from this conclusion, what I wanted to say or to explain is just having the sensor, having the right sensor is okay, but the sensor by itself is not is not sufficient anymore. You need to have the whole system with from the sensor up to the chart and the interface on your tablet, on your smartphone, or on your computer. And in this, I guess that we, of course, can help in many ways. Well, was a bit, I make it maybe a bit quick, but you see few sensors in different cases of application in the IoT. And as I said, the substrate can be very different in relation with the customer needs. Thank you very much indeed for your time, and I'm here to answer to questions.
Thank you very much, Patrick. Are there any questions? Do not hesitate to write in the chat. I think it was very interesting to have all your presentation today. We are a bit late. Do not hesitate to write, because we will need to conclude now the session. Thank you for your participation today. Thank you to all the speakers. As I said, the video will be available. Do not hesitate to see in the B2Match platform to organize B2B meeting if you want, or to send your message, question, exchange with other participants directly there. Yeah, I think we can conclude here. I'm May present. Yes, just to conclude and to show you the next the agenda for next week, as it was mentioned already. Next, hello. So on the 10th of February, we will be having a session dedicated to robot in industry. Please have a look to the agenda, and I think we will conclude here for today. Thank you for your participation to all.